Okay, so this will be a much more technical video. It encompasses some stuff that I want to talk about pertaining to signals, pattern structure, and the segment function. When I say signal, I mean objects like this, like saw or sine. Those are all continuous signals that we can just query and turn into patterns. So this is a much more advanced. This is not, I don't think about this shit when I'm making music, but I think it's interesting enough for me to talk a little bit about. So, say you have a signal, in this case, a saw. I'll be using this for the entire video. So we can use signals to quickly define, patterns to modulate, parameters. So here we have gain going from around 0.1 to 2 over the course of one cycle. So you can hear it starts quiet, gets louder. Just do like 160 of these. Ooh. That's all well and good. Let's use a low pass filter with a high Q value so we can actually hear the change easier and it's not just quiet to loud. So let's say you want to use a saw to modulate a low pass filter value for a looped sample. So it's like you loop at and your slice and everything. And the filter doesn't sound like it's changing. That's because it's not. So it should be like moving from 100 to 800, right? So why does the sine value not update? Well, this is because sine is, or not sine, saw is, or any signal, they're segmented according to the last defined pattern structure. This is almost always the last pattern with a dollar sign to the left of it. So in this case here, it's N0. So for this simple pattern example, we have a kick being played once a cycle, and the low pass filter oscillating between 400 and 2000, slowed down to go over 2 cycles. So we should hear 2 different values for the low pass filter, and we do. So we hear like a low one, and then one that's higher. Now say we use a chop function to chop this kick into 2 halves, where the first half of the kick is played back, and then the second half is played back. But we still only hear 2 values for the low pass filter. There are no other intermediate values. It's just the same value being played twice. So why is that? Because the last defined pattern structure only updates once per cycle. Like this does not count. This is the last defined pattern, and it's once per cycle. And to remedy this, we can't just do, we can't just do this, because this is a completely different pattern. This is 2 kicks, each chopped into 2 bits. Whereas we want this to update over 1 kick chopped into 2 bits. So how do we go about doing that? We use the segment function. So segment takes one argument and operates on a signal and forces that signal to update its value n times in the span of 1 cycle, not just to follow this last defined pattern structure. So in our case, segment 2 we'd get what we want to do. You can hear 4 different values for the low pass filter now. But if you listen, there's something weird about it. The values are completely different. They're like different values. So like the low value and the high value here in the pattern without segment are not present in the pattern with segment. So why is that? So for signals, unscaled signal values go from 0 to 1, but their values, when in a pattern, the values actually start at 1 divided by n times 2, where n is the number of subdivisions required to express the last defined pattern structure. So for a simple example, the number of subdivisions required to express this pattern is just 1. So the start value for this saw signal right here is 1 divided by 1 times 2 is 0.5. So this kick will be fairly quiet. But in this pattern, the number of subdivisions required to express it is 8. So the start value is 1 divided by 8 times 2 is 1/16, which is 0.0625. And this will increment in by 2 for 8 different kicks. So it'll start low and then get louder. Let's make that a little louder. So obviously the math is more complex for like really dense, crazy patterns like this. Like I'm not gonna write this out, but that's the gist of it. That's the basic system. So if we were gonna write all this out for this simple pattern, without the segment, it goes between these two values. Because with the chop, you need, n is 2 in this case. So you have 1 over 2 times 2, and scaled between this and this value, you get 800. So the low pass filter for the low events is 800, and that higher low pass filter value is 1600. But with this segment, you get these 4 values: 600, 1000, 1400, and 1800, which do not overlap with these. So it's good to be conscious of that. But I mean, when you have, you can fix that by shifting this, I believe. Yeah. I'm not going to get it right this time, but. So now our problem is solved, basically. Just toss a segment here and segment it by a lot for something like this, where a lot of different events are happening. And then you can do fun stuff like this. Oh my god, it's 7 minutes. Yeah, I hope that helps.